How do SUID, SGID, and sticky bit work in Linux permissions? Imagine you're sharing a computer with friends or colleagues. You want everyone to do their work, but also keep some things protected. Linux has special permission bits to help with this. These bits are called SUID, SGID, and the sticky bit. They add extra rules to how files and folders behave, making managing permissions easier and safer. Let's start with SUID, which stands for Set User ID. When you set this on an executable file, anyone who runs that file temporarily gets the permissions of the owner of the file. For example, if a program owned by the root user has SUID enabled, any user can run it with root privileges. This is useful for programs like the password changer, which needs to update sensitive system files owned by root. You can see SUID in the permissions with an S replacing the owner's execute bit. To set it, you use the command chmod u+s filename. But be careful, because misusing SUID can give users more access than they should have, which can be a security risk. Next is SGID, or Set Group ID. When you set this on an executable file, the process runs with the permissions of the file's group instead of the user who launched it. When applied to a directory, SGID makes sure that any new files or folders created inside inherit the group's ownership of that directory. This helps keep group permissions consistent, especially in shared workspaces. In permissions, SGID appears as an S in place of the group's execute bit. To set it, you run chmod g+s filename or on a directory. If the execute bit isn't set, it shows as a capital S. Finally, there's the sticky bit. This one is mostly used on directories. When you turn it on, only the owner of a file or the root user can delete or rename files inside that directory. This stops users from deleting or moving files owned by others. The most common example is the TMP directory, where many users can write files but can't delete others' files. In permissions, the sticky bit shows as a T at the end of the permissions string. To set it, you type chmod +T directory name. To sum it up, SUID allows programs to run with the owner's permissions, which is handy for system tasks needing elevated rights. SGID helps keep group permissions consistent and allows programs to run with group rights. The sticky bit keeps shared directories safe by restricting who can delete or move files. These special permission bits are part of Linux's core permission system, giving administrators control over how files and folders are accessed and managed. They are supported across many Unix-like systems, though their exact behavior can vary slightly. Knowing how to use these bits properly helps keep your system secure and organized.